So here we have got a one potentiometer circuit with the help of which you need to determine the EMF of the given dry cell. You need to set up the circuit as shown, then put the key K in this key and take out 1 ohm from this resistance box. Now you need to slide the wire J, you need to slide the jockey on this wire and try to locate the null point J where the galvanometer shows no deflection. Measure the length, this length AJ, and record the same in your answer booklet. Now you need to repeat the same experiment by taking out 2 ohm, 3 ohm, 4 ohm, 5 ohm and 6 ohm, and thereby recording down each time the corresponding length L. Now you need to then tabulate the readings between R and L. Thereafter you need to plot a graph of R against L and then find the L naught where the L intersects the R equals to 0. Then you can find out the EMF by calculating L naught by 25. So this is the experiment. We would try to understand what this experiment is suggesting. Let's go ahead with that. Okay friends, we are about to discuss the determination of EMF of a given dry cell by the help of a potentiometer, and I am going to make one circuit which we are going to use in order to determine the EMF of the potentiometer. As we have already discussed, every potentiometer consists of a potentiometer wire. We call it as AB. Generally in the lab, this wire will be mounted on a 100 centimeter scale, and generally it will have a resistance of 4 ohm. And then there will be a DC power supply. We are labeling it as 4 volt, and in this particular experiment we are going to maintain this DC power supply at 4 volt, and followed by a resistance box with the help of which we are going to introduce a known resistance, or rather I can say we are going to change the resistance of this particular primary circuit. And then I have got a key. Key is there to make or break this primary circuit, and all of them are then connected in series. So what you can do, you can notice over here that this is the positive of the DC power supply, and the positive of the DC power supply goes to the terminal A of the potentiometer wire. So this makes my left end of the circuit. From the right end, I've got a negative of my DC power supply. This goes to one terminal of the resistance box, and from the other terminal of the resistance box I go and connect to one terminal of the key. From the other terminal of the key I take another connecting wire and go and connect it to the end B of the potentiometer wire. Now friends, this becomes my primary circuits. So this is my primary circuit. Now in order to get the secondary circuit, I will be having the unknown dry cell whose EMF I have mentioned as E, and this is what we are looking forward for in this particular experiment, followed by a galvanometer over here. So you can see a galvanometer comes over here. So the negative of the dry cell goes to the galvanometer, one terminal, and from the other terminal of the galvanometer I connect the jockey, and then I connect the positive of this dry cell with the end A of the with the end A of the potentiometer. The other end of the galvanometer will be placed at different lengths. We are going to place this galvanometer at different lengths of this particular potentiometer wire to locate the null point where the galvanometer shows 0 deflection. Now friends, this technique of placing the jockey at different positions on the potentiometer wire to get a null position is often referred in physics as trial and error technique. Friends, we are going to make a proper video in the lab on how we are going to take the readings. Just wait, we are just going to put up that video also in the consequent coming up sessions. So friends, the circuit or the experiment that I have shown you just now, I am just going to put up the animated view what we need to do. So this happens to be our potentiometer wire AB that we have been saying. So this AB wire is generally made up of manganese, and this is 100 centimeter mounted on a meter scale, as you can see. Then I have got a DC power supply or a battery, and there are these two terminals. Then I have got a resistance box varying from 0 to 10 ohm or 1 to 10 ohm, and then I have got a key K. Now all these must be connected in series to make the primary circuit, and then I've got a dry cell followed by a galvanometer and a jockey. Now the positive of the DC power supply goes to the terminal A of the potentiometer wire. From the negative end of the dry cell, I connect one end of the resistance box, where the other end of the resistance box I take a connecting wire and connect it to the key K. From the key other terminal, I connect another wire and join it to the terminal B. Now this brings the entire primary circuit to us. So this is our primary circuit. Now in order to make the secondary circuit, what I am going to do, I am going to connect the positive of the dry cell to the end A, while the negative of the dry cell will go to the galvanometer, one terminal, while from the other terminal I will have a jockey connected, and this jockey will be placed at different segments of the potentiometer wire to locate the null point using the trial and error technique. So this is the physical form of the circuit that has been given in this particular experiment. In this experiment of electricity potentiometer, we need the DC power supply to be set up at 4 volts. So with the help of these knobs, we would set up the voltage at approximately 4 volts. So here I set the voltage to 4 volt. Now you can see the two outputs given, negative and positive. From the negative end of the DC power supply, I connect one connecting wire and take this connecting wire to the one terminal of the resistance box. Now, and ensure that this connection is tied up properly. Now, from the other terminal of the resistance box, I take another connecting wire and connect it to one end of the given key K. Now, from the other end of the key, I connect another connecting wire and take it to the end B of the potentiometer wire. Now, from the positive terminal of your DC power supply, I connect another connecting wire and will take this connecting wire other end to connect to the end A of the potentiometer wire, and thus this will make my primary circuit of the potentiometer wire. In order to make the secondary circuit for the potentiometer, we will take a dry cell. There are two terminals of dry cell, one positive, another negative. From the A end of the potentiometer, that is where the positive of the DC power supply was connected, we connect another connecting wire and take this connecting wire to be connected at the positive terminal of the given dry cell. Ensure that the connections are tight. From the negative terminal of our dry cell, we will connect another connecting wire and take it to connect at one end of the galvanometer. So here I am going to connect this connecting wire other end at the negative terminal of the DC galvanometer. Now from the other end of the DC galvanometer, that is the positive end of the DC galvanometer, I will connect another connecting wire and take its free end to connect to the jockey. So here you can see that I am connecting the other end at the jockey. Thus, the secondary circuit of our potentiometer consists of a dry cell, a galvanometer and a jockey. From end A, that is the positive of the potentiometer circuit, we go to the dry cell positive. From the negative of the dry cell, we go to the galvanometer negative. And from the positive of the galvanometer, then we connect the jockey. That makes our secondary circuit of the potentiometer. Once you have connected the primary and the secondary circuit, you should check the connectivity of the potentiometer circuit by inserting the key and then touching the jockey at end B and noticing the deflection in the galvanometer, and then by touching the jockey at end A of the potentiometer and once again noticing the deflection in the galvanometer. The deflection in the galvanometer must be in opposite direction. If that happens, that shows your potentiometer circuit has been connected correctly. In order to find out the readings, we will take out 1 ohm resistance from the resistance box by pulling out the 1 ohm key, and then by the help of trial and error technique we will try to locate the null point by placing the jockey at different positions of the potentiometer wire. Now while doing that, we will try to find out the null point, and for 1 ohm we find out this null point comes out to be at 49.8 centimeter, and that becomes our first reading. So at 1 ohm the null point comes out at 49.8 centimeter. In order to find out the second reading, we insert the key of 1 ohm in the resistance box and take out the 2 ohm key from the resistance box, so that the resistance now becomes 2 ohm. We will place the jockey at the different positions of the resistance wire and will try to locate the null point. By placing the jockey at different positions, we start getting the deflection in the galvanometer and will try to locate the null point where the galvanometer shows no deflection. And in this case, this point comes out to be 58.8 centimeter approximately. So for resistance R is equals to 2 ohm, the deflection comes at 58.8 centimeter. Reading, we will take out 3 ohm resistance by pulling out 2 ohm and 1 ohm resistance from the resistance box. Once again, we will try to locate the null point by placing the jockey at different positions on the potentiometer wire or the resistance wire. And in this case, we find out the null position or the position of zero deflection at around 68.8 centimeter. So in this case, the null point was located at 68.8 centimeter. So for R is equals to 3 ohm, the null point comes out at 68.8 centimeter. Now for the next reading, that is for R is equals to 4 ohm, we will insert 1 ohm key back into the resistance box and will take out 2 ohm and 2 ohm key out of the resistance box. So the net resistance then happens to be 4 ohm. Once again, we will place the jockey at different positions on the resistance wire or the potentiometer wire and try to locate the null position or zero deflection position. And in this case, the zero deflection positions comes out to be at 77.5 centimeters. So 4 ohm the null deflection position comes out at 77.5 centimeter. Now for 5 ohm resistance, we will take out the 1 ohm key that we have inserted earlier. So it is now 2, 2 and 1 that gives us the 5 ohm resistance effective in the circuit. Now once again, by placing the jockey at different position, we will try to find out the null position or zero deflection position, and in this case the zero deflection position comes out at around 86 centimeters. So for 5 ohm the zero deflection comes out at 86 centimeter. Now for next reading, that is for R is equals to 6 ohm, we will insert all the keys back, that is for 2 and 2 ohm, and ensure that the keys are tightly inserted, and we will take out the 5 ohm key from the resistance box and 1 ohm key from the resistance box, so that the net resistance of the circuit now happens to be 5 plus 1, 6 ohm. Once again, we will place the jockey at different positions on the potentiometer wire and will try to locate the null point. Now this time the null positions comes out around approximately 97.3 centimeter. So you can see I am placing the jockey at different position at around 97.3. The galvanometer shows no deflection, so that point happens to be our balancing length, that is the 97.3 centimeter approximately. So thus for R is equals to 1 ohm to 6 ohm we have taken out the readings, and we will now prepare an observation table for the same. Now the same circuit can be reconnected in another format. Here you can see the resistance box has been removed from this position and has been brought next to the potentiometer wire, and now the connection that I am making is from the positive end of the terminal of DC power supply. I connect it to the one terminal of the resistance box. Then from the negative terminal of this DC power supply I connect one terminal of the key, whereas the other terminal of the key I connect it to the end B, and from the next another terminal of the resistance box over here you can see I connect it to the terminal A. This makes our primary circuit. Now you can see once again in this primary circuit all the circuit elements are connected in series, so this circuit is just similar as the earlier circuit. Then from the positive terminal of the battery, from this dry cell I connect to the end A of the potentiometer wire. From the negative terminal I connect one end of the galvanometer, and from the galvanometer I connect the jockey, and then jockey is once again placed at different position. Now remember, this circuit is similar to the circuit that I have earlier drawn, because the wire which has been taken from the dry cell E goes and get connected at A. Now whenever this circuit is being done, this is the point that you should remember, that where are you connecting the secondary circuit. The change in this connection will make the change in the potentiometer circuit, or else the circuit is going to remain the same. Friends, the same circuit can alternatively be drawn with another way. Let's see, that's the second way of redrawing the same circuit. Here once again I'm having the resistance wire AB mounted on a meter scale, having resistance of approximately 4 ohm, and I have got a resistance box R. Now in this case what you can see, the resistance box is not placed next to as in the earlier case it was placed next to in between the DC power supply and the key. Here I am placing the resistance box next to the potentiometer wire, and then I have got this as a DC power supply D, and then I have got the same key K. Now you can notice all all these things are once again connected in a series. How? The DC power, now in this case the DC power supply positive goes to the one end of the resistance box. From the other terminal of the resistance box I connect the end A of the potentiometer circuit, and then from the negative of the DC power supply I go to one terminal of key K, and from the other terminal of the key I connect to the negative or towards the terminal B of the potentiometer wire. See, it's similar in the aspect that all these elements are once again connected in the series. This is one series circuit that makes the primary circuit. In the earlier circuit that I am redrawing over here, you can again notice all these things are connected in the primary circuit. So this circuit and this circuit are similar. Both circuits are connected in series with the potentiometer wire, so one should not get confused. Now in this particular circuit, what I'm going to do, I'm going to connect the dry cell E once again with a galvanometer. So from the negative of the dry cell I take one end and take it to the galvanometer, and from the galvanometer I connect the jockey, and the other positive terminal of the dry cell is connected to A terminal of the potentiometer wire. Now here also the same thing was done, and this positive of dry cell was connected to the terminal A. Notice that in both the circuit, can you see, the positive of the dry cell goes and get connected to end A. That is what makes both the circuit similar. So the result or the observation table of both the circuit will be nearly the same. So don't get panicked if the teacher varies the circuit in this similar manner. So take care about both the circuits. Both the circuits can be used. They are similar circuits. They will give the same reading. So don't worry about that part. Now let us understand how to draw the observation table of this particular experiment. Now this observation table consists 3 columns. The first column generally is having the serial number, while the second column contains the resistance in ohm, and the third column carries the balancing length L in centimeter. Now if you remember, in the experiment for 1 ohm we have got the 49.8 centimeter as the balancing length. For 2 ohm the balancing length was 58.8 centimeter, and so on. And I have plotted them, or I have written down them in a tabular form. So observation table means to represent all the data that you have calculated or you have obtained in tabular form. Now few of the important points that one should remember while making any observation table. First, that the header of the table must contain the units of the physical quantities that either you are measuring or you are using in that particular experiment. So the header must contain the units. So you can see over here I have mentioned all the units in the headers. The second thing that you should take care in any observation table is the number of significant figures or decimal points. So most of the time in the question paper you will be given that measure this particular thing correct up to 1 decimal point, or do any calculation up to 3 significant figures. So take care about this particular point, because the marks are going to be allocated to you on this particular fact only. So you can see over here what I have done. I have taken all the distances correct up to 1 dp. So 49.8, 68.8 and so on, and see over here 86.0. What does normally the student do? They often casually write down this length as 86 centimeter rather than writing down as 86.0 centimeter. Now this is a blunder mistake, so take care. This is not allowed. This is how you should write down. This is one of the common mistake that you can do in any observation table. The next thing that your examiner is going to see is the trend in the reading. So when I'm saying trend, what I mean to say, when as the R, you can see as the R is increasing, what is happening with the length? the length also increases. So this is what the trend is. So your reading must be trending. So here in this particular experiment, as R was increasing, the length was also increasing. So that's the third thing that the your examiner will look forward into your answer scripts. And the last thing that he is going to take care about is the range of your reading. So range of your reading will be the fourth point, for which he is going to award you the marks. So do remember these four important points. One, DP and SF, DP, SF and units. Let's put up as 1 point. Then the trend of the reading, and the third point happens to be the range. If you are able to take care about these three basic points, definitely you will get good marks in your observation table, or rather you can get the full marks for your observation table. So in order to get full marks on your observation table, remember these 3 points. Friends, thank you for watching. Don't forget to give a like or comment. अगर अभी तक आपने मेरे इस चैनल को सब्सक्राइब नहीं किया है तो प्लीज डू द सेम. Don't forget to hit the bell icon so that whenever a new video is loaded, you get the notification. Take care, and we will meet back again with a new video and a new solution. Thank you, friends.